Hello and welcome to this lesson on standard form. In the first part of the lesson we are going to answer the question what is standard form before looking at how to multiply and divide numbers in standard form and then how to add and subtract numbers in standard form. If you want to navigate to the correct part of the lesson, as always the links are in the video description. Okay, so what is standard form? Well, standard form is just notation which allows us to write really big numbers and really small numbers with ease. In general, it is some number a times 10 to the n. When we write it like this number a is any number between 1 and 9.9 recurring, and the number n is any integer, both positive and negative. An example would be 1.23 times 10 to the 7. When writing with standard form, if the power on the 10 is positive, this means the number that we have is going to be very large. An example would be 1.63 times 10 to the 6. This is actually 1,630,000. The opposite is true with negative powers of 10. If we have a negative power on the 10, this means that the number we have is very small. For example, 2.2 times 10 to the minus 5 is 0.000022. Okay, multiplying and dividing with standard form. Well, just like with fractions, multiplying and dividing with standard form is actually easier than adding and subtracting with standard form. This is the same for fractions, where adding and subtracting is quite difficult and multiplying and dividing is quite easy. And this is strange because normally with numbers, adding and subtracting is the easy bit, and multiplying and dividing is a bit more difficult. So how do we do it? Well, to multiply two numbers in standard form, we simply multiply the two numbers and then we multiply the two tens. But the tens are to a power, so here we have to apply the laws of indices. When we multiply 10 to the m times 10 to the n, we add the powers m and n in our final power of 10. Here's an example. 1.3 times 10 to the 2 times 5.1 times 10 to the 3. As I said, we simply multiply the numbers, 1.3 and 5.1. Here I have written these numbers out, partly to show that standard form is just notation, and we can conduct operations and manipulate these things just like we would with normal numbers. I've also done this to show explicitly what's going on with the powers of 10, much like I did with the proofs of the laws of indices in the last lesson. So 1.3 times 10 to the 2 can be written as 1.3 times 10 times 10, and 5.1 times 10 to the 3 can be written as 5.1 times 10 times 10 times 10. We now have one long list of numbers multiplying together, and because multiplication is communicative, we can rearrange this to get 1.3 times 5.1 times 10 times 10 times 10 times 10 times 10. We then multiply these two numbers at the start, 1.3 and 5.1, to get 6.63, and we have 5 lots of 10 multiplying together, and this is 10 to the 5. Notice here that we could have simply used the rules of indices by adding the 2 and the 3 to get the 5. Here's another example. 3.5 times 10 to the 6 times 1.8 times 10 to the minus 3. Why don't you give the video a pause now and have a go at this yourself before we go through the solution. Okay, so as with the last question, we simply multiply the two numbers and multiply the two tens, each with a power. 3.5 times 1.8 equals 6.3. So we have 6.3 times 10 to the 6 minus 3. 6 minus 3 is 3, and we have our answer of 6.3 times 10 to the 3. Now let's do an example where we divide two numbers expressed in standard form. Here we have 6.8 times 10 to the minus 4 divided by 5.2 times 10 to the minus 5. Remembering that we simply divide the numbers and divide the tens with the powers, why don't you have a go at this yourself before we go through the solution? Okay, so as I said, we simply divide the numbers. So this is 6.8 divided by 5.2. And we divide the tens each with a power. So we have 10 to the minus 4 divided by 10 to the minus 5. 6.8 divided by 5.2 is 1.3. And 10 to the minus 4 divided by 10 to the minus 5 is 10 to the minus 4 minus minus 5, which becomes minus 4 plus 5, which is 1. So we have our answer of 1.3 times 10. Even though there is no power on the 10 here, this number is still expressed in standard form. Okay, so now we're going to talk about adding and subtracting numbers in standard form. Before we go on to this, I want to go through a process which we could call changing the power of 10 for a number in standard form. This is important for two reasons. First of all, if we add together two numbers in standard form and we get something like 11.3 times 10 to the 5, our answer is not in standard form, and we need to change it so that the number is between 1 and 9.9 recurring. This process is also important when adding and subtracting numbers in standard form, because the two numbers will need to be in the same power of 10. More on that later. Let's go through the process for changing the power on the 10 for numbers in standard form. Let's say we had 1.37 times 10 to the 4, and we want to change it so the power on the 10 is a 5. So we're going to have some number times 10 to the 5. The way to think about this is that in order to get 10 to the 4 into 10 to the 5, we need to multiply the entire thing by 10. Therefore, to ensure the value of the number stays the same, we need to divide it by 10 as well. And we do this by dividing the 1.37 by 10 to get 0.137 times 10 to the 5. The overall value of the number has not changed, but it is now expressed in a different form, which would allow us to add it to another number, which is expressed as something times 10 to the 5. Let's say we had the two following numbers in standard form, which we wanted to add together. 1.3 times 10 to the 4 and 3.1 times 10 to the 5. In order to do this, we need to change one of the numbers so that it is expressed with the same power on the 10 as the other. Let's say we want to change 1.3 times 10 to the 4 so that it is expressed as something times 10 to the 5. In order to do this, we need to multiply it by 10 so that 10 to the 4 becomes 10 to the 5. But to keep the value of the number the same, we need to divide by 10. So 1.3 becomes 0.13. Okay, so now let's actually have a go at adding and subtracting some numbers in standard form. Let's say we want to add 1.77 times 10 to the 5 and 4.1 times 10 to the 4. In the first step, we need to change one of the numbers so that both numbers are expressed with the same power on the 10. It's always better in the long run to change the smaller number. So here, let's convert 4.1 times 10 to the 4 into some number times 10 to the 5. We go through our process of multiplying by 10 and dividing by 10, and we get 0.41 times 10 to the 5. The process now is for us to simply add the two number components, and the power on the 10 stays exactly the same. Think of a simple example, like 1 times 10 to the 2 plus 1 times 10 to the 2. This is just 100 plus 100, which is 200, which is 2 times 10 to the 2. The power hasn't changed. The order of magnitude of the numbers hasn't changed. Here, 1.77 plus 0.41 is 2.18, so our answer is 2.18 times 10 to the 5. The process is exactly the same for subtraction. We convert them into the same power of 10, subtract the numbers, and the power stays the same. Here's an example for you to try at home, so pause the video and have a go at it before we go through the solution. 2.7 times 10 to the minus 3 minus 5.9 times 10 to the minus 4. The first step we go through is to convert 5.9 times 10 to the minus 4 into something times 10 to the minus 3. Because we're multiplying the 10s by 10, we have to divide the number by 10. And we get 0.59 times 10 to the minus 3. We're now ready to subtract one number from the other. 2.7 minus 0.59 equals 2.11. And seeing as the power on the 10 stays the same, we have 2.11 times 10 to the minus 3.